Hi, I'm Bob. Let's continue our solutions to section 6.4 about the long-run production in the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. Here is exercise 4.9. The isoquant in the application self-driving trucks is based on two technologies. Suppose that a company develops a third technology that assists but does not replace a human driver. It uses more labor and less capital than the fully self-driving technology, but less labor and more capital than the traditional technology. In the isoquant diagram, the input combination needed to produce 10 chips lies below the straight line, joining the input combinations for the traditional and self-driving technologies. Illustrate the resulting isoquant. The third technology creates another kink on the isoquant. As more technologies are introduced, the isoquant will have more kinks and will begin to resemble the smooth, convex isoquant. Let's solve exercise 4.10. Draw a circle in a diagram with labor surfaces on one axis and capital surfaces on the other. This circle represents all the combinations of labor and capital that produce 100 units of output. Now, draw the isoquant for 100 units of output. Remember that the isoquant includes only the efficient combinations of labor and capital. The circle represents all the combinations of labor and capital that produce 100 units of output. But only the blue part is the isoquant because it includes the efficient combinations of labor and capital. For the other part of the circle, the combinations of the inputs are inefficient. We can reduce both inputs to produce the same level of output. Let's find answers to exercise 4.11. Michelle's business produces ceramic cups using labor, clay, and a kiln. She can manufacture 25 cups a day with 1 worker and 35 cups with 2 workers. Does her production process illustrate diminishing returns to scale or diminishing marginal returns to scale? Give a plausible explanation for why output does not increase proportionately with the number of workers. If the firm increases its labor while holding other inputs constant, we are talking about the marginal returns to labor instead of the marginal returns to scale. The latter is when all inputs increase by the same proportion. In this exercise, holding other inputs constant, the production process illustrates diminishing marginal returns to labor or diminishing marginal product of labor. The marginal product of labor decreases as labor increases, but the total product of labor is still rising. So it is not diminishing return to labor. The reduction is in the marginal sense. The probable reason is that the one additional worker may not have enough materials to operate. Let's solve exercise 4.12. By studying, Will can produce a higher grade on an upcoming economics exam. His production function depends on the number of hours he studies marginal analysis problems A, and the number of hours he studies supply and demand problems R. Specifically, the grade is a Cobb-Douglas production function. The grade production function of his roommate, David, is also a Cobb-Douglas form with different parameters. In Part A, what is Will's marginal productivity from studying supply and demand problems? What is David's? Will's marginal product of studying supply and demand problems is the derivative of the total product with respect to the input R. Similarly, we obtain David's marginal product of R. In Part B, what is Will's marginal rate of technical substitution between studying the two types of problems? What is David's? Suppose we put A on the horizontal axis and R on the vertical axis. Will's marginal rate of technical substitution is the slope of the isoquant. It equals the negative of the ratio of the marginal product of A to the marginal product of R. Similarly, we obtain the marginal rate of technical substitution for David. In Part C, is it possible that Will and David have different marginal productivity functions, but the same marginal rate of technical substitution functions? Explain. Yes, they can have different marginal product functions, but the same marginal rate of technical substitution. Suppose Will's production function is A to the power 1/3 times R to the power 1/3, and David's production function is A to the power 2 times R to the power 2. They have different marginal production functions. Will's marginal product of A is as follows. His marginal product of R is as follows. David's marginal productivity functions are as follows. They are very different because Will has a diminishing marginal product. For example, the partial marginal product of A over partial A is negative. It means as A increases, its marginal product decreases. By contrast, David has an increasing marginal product. For example, his marginal product of A moves in the same direction as A. However, they have the same marginal rate of technical substitution. Notice that David's production function is a monotonic transformation of Will's production function. Let's go to exercise 4.13. Show that the CES production function can be written as the following function. We divide the CES production function by A plus B to the power 1 over rho, and then times the same term. It will not change the value of the production function. C and 1 minus C become the share of the A and B. Let's solve exercise 4.14. What is the marginal rate of technical substitution of the CES production function? We calculate the marginal product of labor and the marginal product of capital, and then use the formula for the marginal rate of technical substitution to cancel some terms and obtain the answer. Let's find answers to exercise 4.15. What is the elasticity of substitution, sigma, of this CES production function? From the answer to the last question, we have the absolute value of the marginal rate of technical substitution. Taking logarithms on both sides gives the following equation. Using the definition of the elasticity of substitution, we get the answer. Let's finish exercise 4.16. Electric power is often generated by burning oil or gas to create steam. That steam is used to drive the turbines and produce electricity. 1 barrel of crude oil produces about 5.6 million BTUs of energy, while 1,000 cubic feet of natural gas produces about 1 million BTUs. Thus, an electric generating company can substitute 1 barrel of crude oil with 5,648 cubic feet natural gas. Draw a few isoquants for this production process. What is the marginal rate of technical substitution? The two inputs are perfect substitutes for producing electricity. The production function is linear. The isoquants for the linear production function are straight lines. The slope is the marginal rate of technical substitution. Thank you so much for doing the exercises with me today. See you tomorrow. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.